So today we're going to talk about paragraph proofs, and I promise eventually we're going to start doing stuff that's not so much writing. We can always do paragraph proofs. You can prove everything in math with a paragraph if you want, but math people don't like to write that much. That's why I've been so grumpy in geometry lately, is because this is not really my favorite part of math, is writing sentences. I can do it, but it's not my favorite part. A paragraph proof is where you can write a paragraph to prove something. So this is exactly from your book, but I know you don't read your book very often, so sometimes there's important things I think you should know. So if you want to prove your conjecture is true, you can use deductive reasoning to do that. This is done by writing a proof, all right? So I want you to write that part. What is a proof? I think it's an important thing for you to write down. A very important word there is a logical argument. Because I said so, right? It might work for your parents when they tell you to do something,
yeah,
but
why not? Because I said so.
In a math world, in a proof world, because I said so, or because it looks like it, right? That's not logical, all right? So each statement you make in a proof has to be supported by a statement that is accepted as true. Like if you can support it with a postulate, or you can support it with something else that we've learned, or a rule, or a definition, that is a statement that can support your reasoning. All right? So if you want to prove something, right? You ever heard someone be like, prove it, right? They say something like, prove it, and then like you can actually show them that it works. That's proof, right? Showing that something works. In math, if you propose something, I think for all whatever this is true, you have to go step by step and prove it. And everything in math that we go by, except for postulates, because we accept those without proof, has a proof. All right? So if you have a conjecture and you prove it, it's then called a theorem. A theorem, every theorem that we learn, Pythagorean theorem is probably the one that you know that you've learned in math class already, has a proof that goes with it that proves that it works for all right triangles. There's actually multiple proofs for it. All right, so when we prove something, we could make a theorem out of it.
Why would you laugh? Why would you laugh?
So here are the steps that we can talk about. And you don't always have to write paragraphs. That's kind of what we're going to focus on today. And honestly, what we do in geometry, we tend to do 2-column proofs, where we have like our statements over here and our reasons over here. That's what we tend to do in high school. But in upper level math, they really probably do paragraph proofs more, just because you can just like write your thoughts out. I took a class last spring, and it was like the worst class of my whole life. And we proved stuff all the time. Like, it was like I cried. I took a quiz one day in class, and then I walked to my car afterwards, and I just cried because I was like, oh my gosh, I'm going to fail this class. It was really, really hard, and we proved all this crazy stuff. And I didn't hardly ever write out like a column proof, which is what we're going to do next week. I tended to write paragraph proofs. So just so you know, paragraph proofs are always okay, but we tend to not do them because we don't like to write so much. Okay? So step 1 is you have to list the given information. And how do you know it's true? It's because it's given, right? That's your given information. Step 2, you want to state what you're trying to prove. Those are easy, right? You state what they give you. You state what they're trying to prove. Step 3 and step 4 are the hard parts, all right? You want to create a deductive argument. Sometimes step 3 can end up being a very long step because you have to go from step to step to figure out, how do I go from A to B? So you want to create a deductive argument by forming a logical chain of statements linking the given information to what you're trying to prove. And step 3 and 4 kind of go together. Justify each statement. Because it looks like it is not a justification. Reasons include definitions, properties, postulates, and theorems that we already have learned. So as we go through this book, every time we learn a new theorem, you can add that to your list of things that you can justify that something's true. Today we don't have a whole lot we can prove because we don't have that big of list of things that we can prove. All we have is our short little list of postulates, and I'm going to tell you one theorem today that you can use. But think about in chapter 5, we're going to have this whole list of things that we can use. And then step 5 is the easiest step. State that you proved what you were supposed to prove. Proven, that's what people used to say. Proven, I don't think you should write that. Alright, so then I have a picture for you over here, right? I don't know if you can fit this in there or not. But step 1 is your given, like your hypothesis, the if part. And notice this is condensed down to 3 things instead of 5. The middle part is the most important. Proving it. Your statements and your reasons, which today are going to be in paragraph form. And then your final step is your conclusion. Based on my statements and reasons, I know this is true. An essay. We're going to write an essay in mathematics.
For every single problem.
The good news is
that still means that it's plural, meaning more than one.
I know, but it doesn't mean an essay. A paragraph could be like 3 to 5 sentences, right? It doesn't necessarily mean it's going to be 12 sentences.
It's like 4 pro.
Yeah, that's like 12 sentences.
That's not true this time, though. But they are proofs. Okay. So the type we're focusing on today is a paragraph proof, and basically you're going to write your statements and reasons in sentence form, all right? We're going to make a paragraph out of it. And so we're going to write a paragraph proof for this problem here, right? And I don't know how much room it's going to fit on here, how small you write. But I wanted to kind of relate the steps to what we're trying to prove so you can kind of see what I'm talking about here, right? But let's just think about this before we jump into the proof. It says, given that M is the midpoint of XY, write a paragraph proof to show that XM is congruent to MY. That seems logical, right? You agree that that seems like that's a true statement? We want to prove it, all right? So, step 1, you always want to state what they give you. What did they give us in this? What did they tell us is true?
M is the midpoint of XY.
M is the midpoint of XY. So my given is M is the midpoint of XY. That's step 1. Write what you're given. Step 2. What are we trying to prove? Emma.
XM equals MY.
XM is congruent to MY, right? That's congruent? And then I think this extra part is helpful. Could we draw a picture using that information that they gave us? Right? That's not really in paragraph form, but I think it's going to help us write our paragraph. Could I draw a picture of a segment XY where M is the midpoint? So I do that. Well, I copy and pasted it. So, does anybody want to volunteer? It's probably not going to be word for word what's here, but how could we logically work through this to prove that XM is congruent to MY? What are some definitions or rules that we could use to say, how do we know this is true? Audrey, what are you thinking? Midpoint formula, but we don't have point, so how could we do that? You know what I'm saying? Like how, I see what you're saying, but I think that without a point to go with it, maybe. Grace, what do you think?
Isn't the midpoint always the, like, dead in the middle, like, every, on the other side, it's always even, midpoint is the
Yeah, I think something about the definition of midpoint on there, which is maybe kind of what you're thinking with midpoint formula, but just not using the whole formula. Like, I think we should say something, I'm going to use lots of if statements, all right? If then. This is what I would say, and then we'll see what the book answer is here. If M is the midpoint of XY, the definition of a midpoint says that it cuts the segment in half. Right? Or it's the exact middle. You agree with that statement? So that means that XM equals MY. Is that true? But they asked me to show that it's congruent, not that it's equal. So how could I go from equal to congruent? Congruent means that it's equal to. So if XM equals MY, that means XM to my. Yes? That's what I would say. That's a lot of writing, right? Alright, let's read what they say and see if I said it somewhat right. You don't have to write every word of this now, but let's just look at it for a minute and see if it says the same thing. If m is the midpoint of xy, then from the definition of midpoint, we know xm equals my. Hey, I said that. Not all of it, but on your homework, yes, you would want to write pretty much this stuff. And then they even go as far to say what equals means, right? Like I think this, personally, I think this sentence, right? This means that xm and my have the same measure. Equals means they have the same measure, so it's kind of up to you if you would write that or not. But then they said exactly what Ali said. We need to talk about what congruence means. By the definition of congruence, if two segments have the same measure, then they are congruent. Or you could say, if xm equals my, the definition of congruent says they are also congruent. So you see kind of that logical way that we went? We used the definition of midpoint. We said that means they're equal, and then we connected equal meaning congruent. That's the hard step of proof, alright? The easy step is given part. Step 5 is say that we proved it. So then I would say, so, xm is congruent to my. That's the last step. Thus, that's a nice statement. Thus, or therefore, we like to say that. Therefore, in conclusion, use all these fancy words.
Thus false, honest, die.
Moreover, that's what we're doing. The thing I don't want you to do is leave it blank, right? Try something. Here's why in college they like paragraph proofs better, because you can just ramble on and hope to get something right, right? In the class I took, every test question was worth 10 points, and even on ones that I had no clue on, I wrote something, and he always gave you at least a 2. Like a 2 meant you got nothing right, but he still gave you 2 for trying. And sometimes I would ramble on and say all this stuff and say stuff that I knew that sort of applied to the problem, and I would get like 6 on it. And I was like, man, I really had no clue what I was talking about, but something I said was true, right? So I want you in proofs, don't leave it blank. Try something, write something, because you know something about midpoints and you know something about congruence, right? Like this is not something we don't know. It's just trying to prove that it's true. Yes?
How many questions would you?
Well, I had our 15-minute class, because it was 5 to 6:15 was my class, but it was every Monday and Wednesday. But I don't know how many questions there were. I guess like 10.
So it's like 100 points a day.
Well, no, on the test, right?
How many questions on the test?
Like 10. But we had quizzes often, and quizzes were 10 points each. And we had a quiz at least once a week. Sometimes on both Monday and Wednesday we had a quiz. And that's when I cried, because I like totally failed a quiz. But you got to drop some quizzes, so that one I cried about, I got a 3 on. I got to drop. But it turned out right. I got a good grade for class.
What's it like crying right now?
It's ridiculous. I don't even want to tell you right now, because I'm ashamed to tell you.
Tell me.
I got an A+ for class. Because he curved things. Because apparently everyone else did way worse than me. So like I set the curve.
Oh.
So I got an A+ in the hardest class of my whole life, which made it feel not even justified. Like I was really grumpy, I got an A+. Because I worked really hard, and I felt like he just gave me an A+. So. My husband said I'm the only person in the world that would complain about an A+.
Yeah.
Like if I would have gotten an A, I would have felt like I kind of earned an A, because I worked really hard. But A+ was just ridiculous. Like who gets an A+? I didn't even know they give you A+ in college. Like it just seemed like a joke to me. But I'll have to show you some of the stuff we did. It was out of control. Okay, once you prove that a conjecture is true, it's now a theorem. So we have this thing, we just proved it. We can now say that there is a midpoint theorem, which hopefully you kind of already knew is true, that if you know a point is the midpoint of a segment, then AM is congruent to MB, right? We just proved that was true.
So if we have to prove something, can we just be like midpoint theorem? Boom. And just stop. Like, do we have to explain it, or can we just
Well,
drop the
right.
word
At some
midpoint?
point, they're gonna ask us a question, and we're gonna use the midpoint theorem, and we can say this is true because by the midpoint theorem, and then it'll be something else added on to that later.
So you gotta
Right?
explain why the midpoint theorem
No.
works, or you
Like
just
now
say-
that we have this, you can use that as a reason. This is true because the midpoint theorem says, or the midpoint theorem says this is true. That's your reasoning.
Oh, that's awesome.
That is awesome, right? That's a lot to remember. So what about this one? It says, given that line AC intersects line CD, write a paragraph proof to show that A, C, and D determine a plane. So before we get to the proof part, let's start with the given part. What do they give me in this?
That AC intersects CD.
Sorry, Garrett.
Sorry, Garrett. Do you want to
Chandler, don't be a jerk. What are we trying to prove? Prove that A, C, and D determine a plane. I don't want to sit down over here and type it. Okay, so do that. Minimum, do that. It just kind of helps you gather your thoughts. What do they give me? What am I trying to prove? So if we're trying to prove that that these 3 points determine a plane, what do you know about determining a plane? What do you have to show for something to make a plane? Eric? That 3 non-collinear points make a plane. So somehow we need to take this given information and show that we know that we have 3 non-collinear points. A picture, I think, would be really nice, but that's not a paragraph proof, right?
I wish it was a picture.
We could draw a picture to help us. Let's draw a picture to help us. AC, yes? Intersects CD, so how do I have to draw CD? With this C, right? So like, I could draw like this, somehow. Do we have a postulate about intersecting lines?
Wait, I don't remember this thing.
The other thing that's hard about proofs is you have to remember all the things you're supposed to remember, right?
Wait, is there an option? Wait, what?
About intersecting lines, about 2 lines intersecting.
2.6. If 2 lines intersect and their intersection is exactly 1 point.
If 2 lines intersect, their intersection is exactly 1 point. I think that's kind of important. Audrey?
If 2 points lie in a plane, then the entire line containing those points lies in it.
If 2 points lie in a plane, then the entire line containing them lie in a plane. Yes, yes. That's true too. So, putting it all together, we better start writing, right? Here's the other thing that's bad about proofs, maybe that you dislike. Is there going to be more than one way that we can write this proof out? As long as you follow logical statements and reasons, it's a right proof. Which means sometimes I might write a proof that takes 3 sentences, and you might take 8 sentences to write the same thing. You kind of take, like, I might go from here to here, and you might go, and still end up there, right? And as we start doing statements and reasons, we'll talk about that. And so, just know, like, there's more than one right answer here, but let's see what I could say here. Since AC intersects CD by whatever postulate or whatever, or you could just say, the postulate says that they will intersect in exactly 1 point. Do you agree with that? Let's see how I can write that. Since AC intersects CD. I'm going to try to short words as possible. I think that's a goal to have, right? Since AC intersects CD in exactly one point, by postulate 2.6, I only know that because I have my notes in front of me. If it was a test, I would say by such and such postulate, or by a postulate says. Could I say then I know A and D are not collinear? You agree with that? If AC intersects CD in only one point, do you think we should say that it intersects that point C? Then their intersection is point C. This means that A and D are not collinear. Non-collinear, maybe I should say that, but that's okay. So I'm using a postulate that says when two lines intersect, they intersect at exactly one point. That point of intersection is C. Therefore, I know A and D are not collinear. I think I'm really close. How do you determine a plane? 3 non-linear points. So I'm going to say, so a plane is determined by 3 non-collinear points. Therefore, see how I like to use these words? A, C, and D form a plane. Proven. I don't think that's the only way. Audrey, you're talking about if two lines intersect and the entire line contains them to form a plane. I think we could use that. I think we still need to somehow talk about knowing that we have 3 non-linear points, but I think we can get there as well. Throw that in there. I see how I started with what they gave me, and I used reasons, like postulates or definitions, to get to that final statement. That's it. That's the proof. I ended with what I was trying to prove, and I think that I did that okay. It's not that fun to write out. If you look ahead past section 2.5, you'll see they're not all words like this, like they're in columns. But on your quiz on Friday, there's going to be a paragraph proof. Go formative, 2.5 check for understanding, or if you don't see it, you can type that code in. And then after you do that, I have homework for you, and you should have some time to work. 30, 31, 32, and 45. 30, 31, 32 are proofs. I think there's 3 proofs there. And only one of them is not. 2, 5, check for understanding. Can you come up?
Well, that is fun.
It's true. Their head's bigger.
Motivation.
Doesn't mean they're smarter, but their brains are bigger.
Yeah.
Their brains are bigger.
Why are they not
Oh no. Is anybody's working?
No.
Well, I guess you gotta go the old-fashioned way.
My internet's not.
Alright, try this and see what happens. Uh-oh.
Is this the page you
It seriously kicks me out.
Anybody getting anything to come up?
I have.
I think it kicks me out of your class.
Oh, no, no,
Yeah,
hi.
it kicks me out of
Please
your
notify
class.
my teacher. I have 2 old ones popped up. Scared.
It kicks me out of your class.
Hey, that's what I think I'm gonna do. Oh, wait. It went away. Oh, it went
It's okay.
back.
Just type that code in and see if it works.
I typed
that goes